Okay, now let us see this example, these three examples. Of course, they are going to add us something on us that we are going to see there when we reach the connected particles. A body of mass 3 kilograms is subject to the force of this and this. Find the acceleration of the body in vector form, then numeric magnitude. Find the magnitude and direction of the force, the direction of the acceleration. Now, they are giving us the body is subject to this force, meaning they are acting in the same direction. So, we first get our resultant force. So, in our solution, our resultant force is going to be, we are going now to add, let us write this on the column form, 2 negative 3, then plus 4, 6. And this one is going to give us 6, then 3. These are going to be in newtons, which you can write as 6I plus 3J newtons. After that, we know that always our resultant force is equal to mass times the acceleration. Now we have this resultant forces here, then we have the mass. We first check, is it in kilograms? Yes. So now our resultant force, which is 6, 3, is equal to 3A. We divide it by 3, our A will be 5 into 6, 3. Our A is going to be 5 times this, we get 2. 5 times this, we get 1. These are in meters per second. Now, after getting this, we have our acceleration. Now, in vector form, our A will be 2I plus J meters per second square. Okay, now here we have got it in a vector form. Now they want us to get the magnitude. So, from here, find A magnitude, part B. Magnitude of A will be the square root of the square 2. Then also a 1, which will be, now our acceleration is going to be root 5 meters per second. Then the one direction, our direction alpha is going to be tan inverse of the J component over the K component. And so our alpha here is going to be 26.57 degrees. That is our direction. As simple as that. To get direction, you get the I component, the base component over the I component. So you get this over this. As simple as that. Now the second note we are going to see here is weight is always equal to mass times the gravity. Our mass should be in kilograms, then we shall get always our weight in that order. Let us see this example. A box of mass 1,000 grams is lowered vertically by a rope. Find the force in the rope when the box is lowered with an acceleration of 4 meters per second. First of all, we first take our mass in kilograms. So our mass now will be 500 divided by 1,000, which will give us 5 kilograms. Now you have the mass, so you can easily sketch this. Now you have a box. Now this box is having 5 kilograms. Now, if it's having 5 kilograms, it means that there is a weight that is going to pull it. So there is a weight that is pulling this box, and this is what we call our weight. Our weight, which we say, is going to be 5 times B. Our weight, remember our weight we say is going to be mass times B, which will be 5G, this weight here. Now it's the one which is pulling that weight. It's the one which is pulling this box when it's lowered downwards. So, at an acceleration, because it's lowered, that means that the acceleration is going to be in this order. Always indicate your acceleration is in that order, and it's 4 meters per second squared. Now, because this one is being lowered, there is a force of force, what in most cases we shall be calling it tension in that spring that is going to be pulling that force between the box of that weight, the weight of that box, and then the rope. That's what we call it. So there is always a force that is pulling it up. In simple terms, some people call it reaction or the tension in the ropes. Okay, so after having that, now that we have acceleration, we have this. So first get our resultant force. Because the body is going this side, so always our Fr, the resultant force is equal to mass times acceleration. So it's that the body is going downwards. So meaning, if it's going downwards, this is the force which is pulling. So I said 5d now minus this d. It will be giving me the mass, which is 5 kilograms, then times the acceleration, which is 4. So from here, so that from there, you can easily see by hour, this will be 5 into 9.8 minus d equaling to 20. From there, if I'm trying it here, so that this one, might now will be, now this one, okay. People will get lost. So when you take this side, you'll be having 5 into 9.8, then minus 20. And so our tension is going to be, it is going to be 29 newtons. So meaning this force that is reacting to this box is going to be of force 20 newtons. As simple as that. What do we note here? Always mass will be given in kilograms, then weight is equal to mass times gravity. That is our idea there. So now we come to this one also. Our rope is pulling a box of mass 100 kilograms upwards. Now they are pulling it upwards. So a part, let us call this our part there. Okay. So there is a rope pulling it upwards, meaning there is a force that is pulling this thing upwards. Let us call it D. Okay, of mass, this one is having 100 kilograms. Of course, if it has 100 kilograms, there is a weight acting on it. So this weight, so our weight is going to be mass times gravity, which will be our mass sits in kilograms, so I can easily write it like that. So there is weight, which is going to be 100 G acting downwards. I mean, it depends where it's going, but it's pulling it upwards. So, mean that this force is greater than this. So, now we indicate that our acceleration is in that direction, and it's 0.25 meters per second squared. This is pulling it upwards like that. I think you can see these are very easy things. You need to know what is going to guide you, which direction is the particle taking. So this one is moving now up. As you all know that using the Newton's second law of motion, the resultant force should be equal to the mass of the particle times its acceleration. What's the resultant force? We base on the direction. So that is now the body is accelerating in that direction, because we say the acceleration of the particle and the force are acting in the same direction. So our force is going upwards. What is it taking upwards? So this one is taking it upwards. So there we say T now minus what is opposing. So what is opposing that which is acting down? This one, which is 100 G, equal to the mass of the particle, which is 100, and times acceleration, which is 0.25. As simple as that. Here is true. Now here what was pushing it was this force. That's why it's attracted this fast, because this was pulling. Because of this acceleration, it was going downwards. That's why you get this minus this. But now this one is taking it up. What is taking up? This one. So get this and minus this. I think you get the difference. Okay. Here say T minus 100. Our gravitation force is going to be this, unless the question states otherwise. If it doesn't, take it to be 9.8. Then this times this, I think we get 25. So our T minus this would be 980 equal to 25. Take this inside, so that our T is going to be 1005 newtons, and that will be the case. As simple as that. Now, when we have these bases, now you are going to find connected particles very easy. I wish you will. Let us see how we now. Let us see the reaction. What is the reaction? We are going to see reaction and then resolving. Now these forces, we are now going to resolve forces along the plane. When you know how to resolve what's around the plane, this is going to be very easy. Watch the next lesson.